Hello, class. I'm here today, and I'm going to answer just a couple of questions that a few of you had regarding cardiac muscle, and really the difference between the pacemaker cells of cardiac muscle and the regular cardiac myocytes. So here are a few basic things that I wrote down. The pacemaker cells, these are found in the SA node, the AV node, the bundle of His, the bundle branches, the Purkinje fibers. These represent about 1% of all of the cardiac muscle cells. They are in the region called the intrinsic conduction system, and those cells, they are autorhythmic. They have really two roles. They initiate depolarization. They are autorhythmic. They do that on their own. They don't need the nervous system to initiate depolarization. The nervous system does impact these cells. It can cause them to depolarize faster or more slowly, or to reach threshold faster or more slowly, but it does not initiate depolarization. What that pacemaker action potential looks like is something like this. There is a slow phase of sodium influx. That's what's called the pacemaker potential, or funny current, or unstable resting membrane potential. Once threshold is met, then there's a rapid influx of calcium followed by efflux of potassium, repolarizing. And then again, sodium influxes slowly. Once threshold is met, rapid calcium influx followed by rapid potassium efflux. That's the pacemaker potential. This potential is occurring, again, at the SA node, the AV node, the bundle of His, the bundle branches. This action potential is what initiates depolarization in the rest of the myocardium as it spreads through the intrinsic conduction system. Let's just label that before we move on. So here, that really is that unstable resting membrane potential right there, or funny current. That's caused by sodium influx, which is slow. I wrote an I there for influx. Right here, once threshold is met, that is calcium influx. And then we have potassium efflux, leading to repolarization right here. Now, to the right, let's look at a regular cardiac muscle cell's action potential. So here is rapid sodium influx. After sodium influx occurs, then we have these voltage sensitive calcium channels. They open at the same time as the potassium channels open, and we get this unique phase called the plateau phase right here. When this is happening, if I were to draw a cell for you, calcium is influxing at the same time that potassium is effluxing. So what happens is you get this prolonged plateau phase. So you have potassium efflux and calcium influx occurring at the same time. Right here, now this rapid depolarization, that was just rapid or fast sodium influx that's occurring right there. And then once the calcium channels close, the cell repolarizes because essentially potassium efflux wins the day. So potassium continues to efflux really from here through when the cell is repolarized. So it's a little different. Two potentials, two different patterns of depolarization. Again, this is what happens is pacemaker cells, slow sodium influx occurs, reaching threshold, then you get rapid calcium influx followed by rapid potassium efflux, repolarizing the cell. This over here, this is a regular cardiac muscle cell. So once this wave of depolarization spreads to the rest of the myocardium, those regular cardiac myocytes have a pattern like this. Rapid sodium influx to peak depolarization, calcium influx with potassium efflux, prolonging that absolute refractory period to about 250 milliseconds. And then potassium efflux causes that repolarization phase. Okay, I hope that helps. I hope that answers many of your questions. I hope that helps you to organize your thoughts and ideas related to cardiac muscle. Have a great day.